Hi friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 692. Top key frequent words. In this video, we're going to share several solution formats based on modifying sorting keys. First, I'll read through the statement to digest the problem requirements, and then we do a simple analysis, and finally we share the code and analyze the code. First, the statement. So given an array of strings called words and an integer key, return the key most frequent strings. Next paragraph specifies the return requirements. So return the answer sorted by the frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. So this is the main statement for this problem. Now let's look at one example. Let's look at example 1. So in example 1, so key equals 2. So in this list, so the words I appears twice, and love appears twice, and coding appears once. So we need to return I and love. However, we need to pay attention to the order. We need to first return I and then return love, because I is lexicographically smaller than love. So this explains example 1, or interpreted example 1. So before we look at the treatments, let's look at the constraints. First, the length of the words is not empty first, it's bounded above by 500. So 500 actually is not a very large number. Secondly, each of the words has a length bounded below by 1, in other words, not empty, and bounded above by 10. And the third one is about the letters in the each of the words, and the last one is an consistent assumption, because here k is less than or equal to the number of unique words. So with that said, let's look at the treatment. So this problem, due to the problem size, actually is a relatively easier problem. So here our treatments are all based on modifying the sorting keys. So it depends on what formats or representations you would prefer. So we can have different formats of solutions. So the overall idea is the following. So we could modify the sorting keys according to the problem requirement. So here I want to define an order relation or less than relation. So let WK be the word frequency tuple. So or you can regard it as a mixed vector. So we can define an order relation given by equation star. First, we are going to consider the frequency. If the frequency is smaller, so we regard that this tuple is smaller. So for example, the K1 is less than K2. Or if the frequency is the same, then we regard that if the word has a larger lexical order, so we regard it as small. So as long as to why we define this like this, so we'll make it clear when we do the coding. The reason is that we're going to use a heap. So when we use the heap, we're going to monitor the heap length. If the length exceeds the required length key, so we're going to do pop operations. So we are going to pop the min elements. So then we left the max element. So we want to left those with larger frequency, or if the frequencies are the same, we're going to retain the ones with smaller lexical order. So we write W1 greater than W2 here in star. So in the specific coding, so we could use a star to define sorting keys, or we can modify the magic method in a class. So we are going to do both. So before we do the coding, so here is extension or comparison. So actually the idea used here works totally fine for problem Leetcode 347. But the difference is that in problem 347, so the objects we are dealing with are numbers. But here in this problem, the objects we are dealing with are strings or words. So as a side remark, so actually we can devise a solution by incorporating the trial abstract data structure, because we are dealing with strings. But that's too much a detour, so we will not do that here. So with that said, we are ready to look at coding. So we are going to first write a one that is most direct and verbose. So here first I'm going to get the words, unique words, and their frequencies. So let's see, we're going to use collections counter, right? So the words. So this will give us the unique words and their corresponding frequencies. Then actually we can sort the corresponding unique words. So let's first get the unique words. So count case, and then we do sort. So let's see, we do sorted. So let's sort this case according to key. So lambda so x. So I'm going to sort first. I want the larger frequency in front. So let's go to count x, and then I want the smaller lexical strings in front. So this is the secondary sorting component. So with that done, so actually we can return case. So we want to return the key, first key. So this is actually a solution format. This is very straightforward. Let's first do a check. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the generic cases. So now let's use another ingredient. So let's copy this function signature and change this one to be v1. And now let's make it here. What we are going to do, we're going to use some functions in this module, heap_q. So we're going to use the n smallest. So here, actually, this is still very straightforward. So what we want to specify is the n, iterable, and k. So for n, this for short is k. The iterable will be the unique words, and the k should be defined as above. So now let's look at the solution here. So what we're going to do is that let's first get the counters. Let's counter words. And then what we're going to do is to do the return. So what we're going to return, let me first make a result variable to explain it clearly. So we're going to use the heap_q in smallest, right? In smallest. So the number of elements we want to return is k, and the heap we're going to consider is that is the counter case, right? And the k is going to be, because here I'm using smallest, I want to find the smallest one. So that is count x and x, right? So with that done, so actually we can do the return. So we can return the result. Let's do a check. Yeah, it passes. So now let's look at generic case. Yeah, that's the second version. So these two versions actually are the same. So now let's look at another version. So let me copy this class signature and the function signature for the main function. So for this one, let's change the original one to be b. So we want to write a wrapper class to to store the information for the frequencies and countings and all the unique words, and then we want to modify the dunder less than function or the magic method. So this is actually a treatment we have used quite a number of times, right? So here let's first do this and then explain. So let's write a class. I'm going to call it word and frequency, right? So then the initialization actually is simple. So we can self word and frequency, right? So we're going to self. So we just need to use one data field. So an attribute, that would be enough. So word frequency, right? Then we are going to overwrite the dunder less than function. So self. So now self represents a object in this class and other another object. Then what we're going to do is to return. Let's first check their frequency, right? So self atom, so 1. So if the frequency is smaller, so we regard it smaller, right? Atom 1. Or otherwise, if self atom 1 equals self other item 1. In other words, the frequencies are the same. Now we're going to consider the order self item 0, right? So we want to make this one larger, so to regard it as small. So here, this order is due to the fact that we're going to use heap, and then we want to pop the min elements, but we want to retain the lexical smallest one, right? So that's why we have this order. So with that said, let's look at the solution logic. So this is actually very straightforward. So here we're going to get collections, counter words, and then we can initialize a heap. So here going to be empty at first. Also, I'm going to introduce a variable called length to check how many elements are currently in the heap. So next, we're going to iterate. So for word and frequency in count items. Then what we're going to do is that we push the corresponding wrapper object into the heap, right? So here is heap q, heap push. So we are going to push into h, and the object we're going to put is word frequent. And so we have word and we have frequency, right? So this word frequency is really a wrapper class incorporating the two pieces of information. So now each time we push an element to an object to the heap, we're going to increment the length by 1. So next we're going to check if length is greater than k. So in this case, so we're going to do heap pop, heap q, heap pop. So we're going to pop from h, right? So this logic will make sure that the final length of h is at most is exactly k, I would say. So in if we look at all the process for the for loop, the length of the heap will be at most k, right? So of course, if it's larger than k, we want to pop that one to make k a cap. So with that done, so we are going to do the return. So actually we want to make sure the order. So for object item 0, right? So we are going to return the unique words. So for object in, so I'm going to use sorted again. Sorted h, so reverse equals true. So actually here, when we do the sort, we used again this dunder function. So with that said, this forms another format of solution. So let's do a check. Yeah, it passes one example. Now let's look at generic case. Yeah, it passes all the generic cases. So with that done, so I guess that's about it for this problem. So in this video, actually we shared some solution treatments based on modifying the sorting case, either in a vanilla sorting function, or we can override the dunder less than function using a wrapper class. So with that said, I guess that's about it for this video. Thank you.